Welcome back, students. Let us take 10th question today. If f from 1 to 3 to ABC given by f of 1 is equal to A, f of 2 is equal to A, f of 3 is equal to B, then you need to check A 11.2 into but not 1 B bijective. Welcome back, students. Today, let us take the question if f from 1 to 3 to ABC given by f of 1 is equal to A, f of 2 is equal to A, f of 3 is equal to B, then you need to check whether f is 1 1 or 2 bijective or into. Okay. So f of 1 is equal to A. F of 2 is also equal to A. F of 2 is also equal to A. So Hi students, welcome back. Let us take the question. If f from 1 to 3 to ABC given by f of 1 is equal to A, f of 2 is equal to A, f of 3 is equal to B, then you need to check whether f is 1 1 or 2 into or bijective. Okay. So given f of 1 is equal to A, f of 1 is equal to A. F of 2 is also equal to A, correct? So since 1 and 2 map to A only, then it is not 1 1. Why? Because distinct element should map to distinct image. Then only it will be 1 1. So you can directly discard the first option. It is not 1 1. Okay. You check now onto. How do you check onto? All the image should map to some image of pre-image of F. So A has pre-image 1 and 2. B has pre-image 3. But C does not have any pre-image. Therefore, it is not onto also. A has pre-image 1, 2 both. B has pre-image 3. But C does not have any pre-image. Therefore, it is not onto. See here, in the codomain, if all the elements have pre-image, then it is onto. Therefore, it is not onto. If a function is not onto, then it must be into. See the next option, into but not 1 1. So this option is correct. Last option is not correct because the function is not 1 1, not onto. A function is bijective only when if it is both 1 1 and onto. Got it? Thank you. Hi students, take the question. If f and g are functions with f from a to b and g from b to c, then the domain of g composition f is. You need to check whether it is A, B, C or A intersection B. See, first of all, composition is possible or not. You need to check. F is from A to B. G is from B to C. See, the codomain of F is domain of G. That condition should be there to have composition mapping. So G composition F is possible now. So how do you write G composition F of X? It is equal to G of f of x. Correct? See, the input for G is f of x. Correct? Input for G is f of x. And G maps to C. Correct? So see here in the image also. Then G composition F will be mapping from where to where? It is mapping from A to C. Correct? So the domain of G composition F must be A. Got it? So see the option. Option A is the correct answer. So domain of G composition F is A because G composition F is a mapping from A to C. Got it? Thank you. Hi students, let us take the question. If f of x is equal to x square on R and g of x is equal to root x on closed interval 0 to infinity. Infinity side you have to have open interval. Then G composition F is defined. You need to check the options defined on R but only gives non-negative values 0 to infinity, minus infinity to 0. Okay. So G composition F again. G composition F of x. The domain of F is R and domain of G is 0 to infinity. If F is from A to B, G is from B to C, then G composition F will be from A to C. See the domain here, it is R. Domain of F is R. So G composition F is defined on R. Okay. See here the domain is restricted because inside the square root you cannot take negative value. Therefore, here domain is restricted. And of course, here range is x square range will be always non-negative. So that is also 0 to infinity only. The range of f is 0 to infinity and domain of G is 0 to infinity. So G composition F is defined and domain of the G composition F is R. So option A is correct. You can discard B, C and D. Thank you. Hi students, let us take the question. A relation R on a set is symmetric if, what is the definition of symmetric? Definition of symmetric is for all A belongs to A, for all AB belongs to A, AB belongs to A, if AB belongs to R, that implies BA, take ulta, that is also there in R, then it is symmetric. For example, in R, if you have 1, 2, if 2, 1 is also there in R, then R is symmetric. Check the options. AB belongs to R implies AA belongs to R. It should be BA. So you can discard the first option. Second option, AB belongs to R implies the ulta BA belongs to R. So that is the condition for symmetric. So option B is correct. Option C is also not correct. And D is also not correct. So the final answer is option B. AB belongs to R implies BA belongs to R. Got it? Thank you. Hello everyone. Let us take the question. If R is antisymmetric and AB belongs to R and AA belongs to R, then you need to check whether A is equal to B, A not equal to B, AA belongs to R, or none of this. What is the definition of antisymmetric? What's the definition of symmetric? What's the definition of symmetric? AB belongs to R implies BA belongs to R. That's the definition of symmetry. If you add one more condition along with this, actually AB and BC should be there in R. AB and BC should be, AB and BA should be there in R. One more condition, if you have A is equal to B, then that is called antisymmetric. This implies A is equal to B. That is the condition for A is equal to B. So for antisymmetric, along with AB belongs to R and BA belongs to R, you should have A is equal to B. Suppose in a relation 1 or A, B and BA both are there. If A is equal to B, then it is antisymmetric. Therefore, option A is the correct answer because already AB belongs to R, they have given. AA also belongs to R. Then this condition it should satisfy. Okay, that is the condition for antisymmetry. This is wrong, this is wrong, and this is also. So answer is A is equal to B. Okay, got it? Thank you. Hi students, let us take the question. If f of x is equal to sin x as a function from R to R, then you need to check whether f is on 2 into 1 1 or bijective. Okay, so f of x is equal to sin x, correct? If the function is 1 1, then you need to check this. You have to assume f of x1 is equal to f of x2, then x1 is equal to x2. See the domain and range. Domain is also R, range is also R, correct? Domain and range both are R. So is it possible to have for each element there is distinct image? For example, what is sin 0? Sin 0 is, what is sin 0? Sin 0 is 0. What about sin pi or 2 pi? It's also 0. So this 0 and 2 pi both have same image. Therefore, f is not 1 1. Got it? Got it right? So sine of 0 and sine of 2 pi both are 0. So both 0 and 2 pi have the image 0. Therefore, f cannot be 1 1. Now check on 2. Sine value always lie between -1 to 1. So in the codomain, you have 2, 3, 4, all real values. Except from -1 to 1, the rest of all elements will not have pre-image. Therefore, f is not on 2. Except -1 to 1, the rest of the elements will not have any pre-image. Therefore, f cannot be on 2. So you can discard first option on 2, third option 1 1. If it is not 1 1 and on 2, it cannot be bijective. To be bijective, it should be 1 1 and on 2. So the option always a function is not on 2 means it is in. Therefore, final answer is option B, into. Got it right? Thank you. Hi everyone. Let us take the question. If f from R to R is defined by x, r, y, if and only if x less than or equal to y, then the relation R is, you need to check, reflexive, symmetric, transitive, or equivalence, even antisymmetric. Okay, what is given? The relation is defined x less than or equal to y. Okay, x less than or equal to y. Since less than or equal to is there, x can be equal to x. Correct? So R is reflexive. Correct? Correct? X R x holds. Therefore, it is reflexive. Now, if x less than or equal to y, is it possible to have y less than or equal to x? Y less than or equal to x? For example, 1 less than or equal to 2. Can I write 2 less than or equal to 1? It's not possible, right? Therefore, f is not symmetric. F is not symmetric. So F is, sorry, R is not symmetric. Relation you need to take, not function. R is not symmetric. R is reflexive. R is not symmetric. Next, check transitivity. So let me take 3 elements. 1 is less than or equal to 2. 2 is less than or equal to 3. Then can I say 1 is less than or equal to 3? Clearly it is true. Therefore, R is transitive. R is transitive. Okay. So R is reflexive, not symmetric, and transitive. Since it is not symmetric, it cannot be equivalence relation. You can discard this too. Reflexive and transitive only. We have proved it is transitive and reflexive also. Therefore, option A is correct. Okay. Since it's not symmetric, you cannot take this also. Therefore, final answer is reflexive and transitive only. Option A is correct. Thank you. Hi students, take the question. If f from A to B is bijective, then it has no inverse, a unique inverse G from B to A, many inverses, an inverse only if A is finite. Okay? Now, so don't take function. Suppose A is an element. Okay? Then what is the inverse, multiplicative inverse of this? It's 1 by A. Any other inverse is possible? other than 1 by a. What's the condition for inverse? A into 1 by a must be multiplicative identity, correct? Or if you take additive inverse, for 1 you have minus 1 is the only inverse, correct? Because 1 minus 1 is equal to 0. So always, whichever the case, function or any element, if inverse exists, it must be unique. Okay? In function, the reverse mapping you should take for inverse. Suppose f is from a to b, then f inverse will be from b to a. And f inverse will be identity mapping. Okay? So, this will be identity mapping. And f inverse will be like other cases, it must be unique. Here in this case, f inverse is taken as g. G will be from b to a. Therefore, which option is correct? A unique inverse g from b to a. So always inverse, if it exists, whenever function is bijective, inverse exists. If it exists, it must be unique. Okay, inverse will be unique. You cannot have two inverses for same function. That's what it is. Okay, got it right? Thank you. Hi students, let us take the question. If f and g are invertible, then G composition F inverse equals to, you need to check A, F inverse composition G inverse, G inverse composition F inverse, F composition G, G composition F. Actually, proof is not there in your syllabus, and this result you can use. Always remember, if G composition F it exists, if it is bijective, then decomposition F inverse exists. And decomposition F inverse is F inverse. You need to take the second element first. Inverse of that composition G inverse. Okay, it is second element first. F inverse composition G inverse. You need to remember this result. Okay, G composition F inverse is equal to F inverse composition G inverse. So option A is the correct answer. This is second element you need to take first. So it is not correct, not correct. Final answer is F inverse composition G inverse. That is the answer for G composition F inverse. Thank you. Hello everyone. Take the question. If R on set S has exactly one equivalence class, then R is option A, universal relation S cross S, option B, identity relation, option C, empty, option D, anti-symmetric. Okay. C. R is the relation on set S. R is the relation on set S. It has only one equivalence class. That means suppose there are elements A, B, C and all, then A equivalence class A is equal to equivalence class B because it has only one equivalence class. Equivalence class C that must be equal to S, right? Because S is the whole set. It must be equal to S. Then its universal set must be S cross S. So then R should be S cross S. Cartesian product of S with itself. That is actually universal relation. So option A, universal relation S cross S is the correct answer. Okay, whenever you have only one equivalence class, then R must be universal relation S cross S. Got it? Thank you. Hi students, take the question. Let f from n to n be defined by fn is equal to n plus 1. Then you need to check f is 1 1 on 2 bijective or neither. Okay, even f of n is equal to n plus 1, correct? And the domain is n. So n means you can take elements from 1 to so on, correct? You cannot take 0. Okay, set of natural number. So when f is n is equal to 1, what is fn? It is 1 plus 1, 2, correct? Then f of 2 is equal to 2 plus 1, the next number 3. F of 3, the next number 4. Like that it continues, correct? Now check whether the function is 1 1 or not. Okay, so if you can take the contrapositive of f. How do you take contrapositive? Suppose general way is f of x1 is equal to f of x2. Then you need to prove what? You need to prove x1 is equal to x2. Contrapositive means suppose P implies Q, you need to prove not Q implies not P. That is, this is direct statement. This is contrapositive statement. So, if you take 1 not equal to 2, then f of 1 is clearly not equal to f of 2 because f of 1 is 2 not equal to f of 2 is 3. Therefore, f is not 1, 1. Correct? F is not 1, 1. Now check on 2. What you have to do? For each image, you should find pre-image. Correct? Now, 1 is also there in codomain. 1 is also there in codomain. What is the pre-image of 1? You don't have any pre-image. It will start from 2. Therefore, f is not on 2. Are you getting? See, all other elements have pre-image. Only 1 does not have any pre-image. Therefore, it is not 1 on 2. We have proved f is not 1, 1. F is 1, 1 actually we have proved, and it is not on 2. If contrapositive method we have used, it's 1, 1, but it is not on 2 because 1 is not equal to 2 we have taken, and we have proved 2 is not equal to 3, or f of 1 is not equal to f of 2. That is the other way of proving 1, 1. Therefore, f is 1, 1, but it is not on 2. Okay. So, the option A is the correct option. Option A is correct. This is not correct. Since it is not on 2, it is not bijective, but it is 1, 1, so you can't take neither also. So, F is 1, 1 only. Got it? Just remember contrapositive method and follow the contrapositive method. You will get the required answer. Thank you. Hi everyone. Take the question. An onto map from A to B implies option A, mod A is greater than or equal to mod B, mod option B, mod A less than or equal to mod B, option C, mod A is equal to mod B, option D, None of these. Even F is on 2. Correct? F is on 2. Means all the elements of B must have pre-image. Means all the elements of B must have pre-image, means at least B should have same number of elements as A or more than that. Mod A means number of elements in A. Mod B means number of elements in B, or cardinality. Number of elements, we call it as cardinal number. Cardinality of B, mod B. Cardinality of A, mod A. So onto means all the elements of B must have pre-image. Suppose there are 6 elements in B, then A should have 6 or more than that. To have all the elements should have pre-image. Therefore, A should have 6 or more than 6. That means mod A must be greater than or equal to mod B when the function is onto. Always domain should have more image or equal image as codomain. Okay, got it right? So option A, mod A greater than or equal to mod B, or cardinality of A must be greater than or equal to cardinality of B. That is the required answer. Thank you. Hi students, let us take the question. If f from A to B is bijective, where A and B are finite, then you need to check option A, mod A greater than or equal to B, option B, mod A less than or equal to B, option C, mod A equal to B, option D, none of these. Okay. So what is given? F is here. F is here. F is here, bijective. F is bijective means F is 1 1 and on 2. Okay, F is 1 1 and on to both. So to be on 2, you should have mod A greater than or equal to mod B. Number of elements in the domain must be more than number of elements in codomain. And to be 1, 1, you have to have the reverse case. Number of elements in A less than or equal to number of elements in B. Combine these two, you will get mod A equal to mod B. Why you should combine? Because if a function is bijective, it should be both 1, 1 and onto. So combine both the condition, you will get mod A is equal to mod B. Therefore, a function is bijective, then number of elements in domain must be equal to number of elements in codomain, or cardinality of A must be equal to cardinality of B. So option C is the correct answer. Got it? Thank you. Hi students, let us take the question. If R on set is defined by X, R, Y, if and only if X is equal to Y plus 1, then you need to check the relation R is reflexive, symmetric, transitive, or none of the above option. So relation is on Z, they have given, and the relation is defined as X is equal to Y plus 1. Check whether it is reflexive or not. How do you check? Take Y also equal to X. Is it possible to have X is equal to X plus 1? In any case, it is not possible. Is it possible? Not possible, right? Number is equal to next number. It's not possible. So, R is not reflexive. Correct? Now, check the symmetric condition. Suppose X, R, Y. That implies X is equal to Y plus 1. Then is it possible to have Y R X? X is 1 more than Y. Y R X means Y is 1 more than X. Both the condition, is it possible? This is given. If X is 1 more than Y, Is it possible to have y is 1 more than the x? It's not possible. Therefore, R is not symmetric. Correct? R is not symmetric. Now you take x r y and y r z. What do you mean by x r y? X is equal to y plus 1. What do you mean by y r z? Y is equal to z plus 1. Then replace here y by this value. So x is equal to z plus 1 plus 1. So it is x is equal to z plus 2. But the relation is should be x is equal to y plus 1, this form. But here z plus 2. If it is z plus 1, then you can say x r z. But now it is z plus 2. Therefore, x r z. It is not true. It is not true. Therefore, R is not transitive. Therefore, R is not transitive. Now check the options. R is not symmetric. R is not reflexive. R is not transitive. So option D, none is the correct option. Got it right? Thank you. Hi students, let us take the question. If F is not injective, then it cannot be bijective. It might be on to both A and B, none. So check which one is correct. What is given? F is not injective. Not injective means F is not injective means F is not 1 1. Injective 1 1 both are same. Surjective on to both are same. If F is not injective, definitely it cannot be bijective, because to be bijective it should be both 1 1 and onto. F cannot be bijective, but F can be onto, or sometimes it may not be onto. Sometimes both possibility is there. For example, 1 2 3, 1 2. Okay, so I can map this to this. this to this, this to this. Now, F is not 1, 1, but it is on to, correct? But it is on to because it is mapped to both the elements of the codomain. Okay, if it is not 1, 1 because both 1, 2 map to 1 itself. Next, one more case I can take. In this case, it's not injective, but it is on to. Now, if you take 1, 2, 3, A, B, C. Okay, same way you can take. Now, it is not injective and it's not on to also because this C is not having any pre-image. It does not have any pre-image. Therefore, it is not onto. So both the cases are possible. So F may or may not be onto. So option A and option B both are correct, but you cannot in CET you cannot have more than one answer correct. Check this option C, both A and B. Both A and B are correct. So you mark this option as correct, these two as wrong. In CET, only one option should be correct. Okay, more than one option correct. That type of question will not be there in KCET. Okay, so option C, both A and B, that is the correct answer. Okay. So the final answer is option C, both A and B. So be careful by seeing first option. If you tick, that is not correct. Check all the options, then you decide which one is correct. Okay, thank you. Hi students, take the question. If R is defined by has same reminder modify, then R is check whether it is equivalence, transitive, symmetric, antisymmetric, or reflexive. Okay. So what do you mean by A mod A is equal to B mod phi? What that means? Congruence modulo function. A is equal to A is equal to A is equal to B mod phi. What it implies? Or A is equal to B mod n. You can take general